Hello, this is Cogitator Learning. This video lesson is the first part of a three-part series where the basics of vector algebra is being tackled. This video lesson is useful for students who are in grade 11 CBSE or ICSE board and is useful for students in grade 10 of IGCSE board. So let's talk about vectors. What are vectors? Vectors are physical entities that have both magnitude and direction. This is the textbook definition. Let's try to understand this in a simple way. The question, what happens if I push a table? Well, if I push a table in this way, nothing will happen. All right, what happens if two folks push a table, push a box, not from the top? Maybe this way, or maybe this way, or maybe this way. So what do we understand from this? If I just say pushing or pulling a box, it is not sufficient. For us to answer the question, what happens to the box, we need to know how these forces are being applied, or in other words, what is the direction of the force. Magnitude of force merely means the strength of the push or pull. For example, 5 newtons, 10 newtons, etc. All right, we have understood what vectors are and how and now we need to know how some of the vectors in physics are categorized as scalars or vectors. The physical entity description is given. Force is a vector. Time is a scalar. Mass, you guessed it right, it's a scalar. Displacement, vector. Acceleration is a vector. Current, surprisingly, is a scalar. Work is a scalar. Electric field is a vector. Kinetic energy, potential energy, or energy in general is a scalar. Potential difference is a scalar. Momentum is a vector. Distance is a scalar. Magnetic field is a vector. Torque is a vector. The units of all these physical quantities are given column number 3. All right. Now we have an understanding of what vectors are and how some of the physical entities that are used in physics can be classified as scalars or vectors. Now the question is, how do we represent vectors? Supposing I say I want a force F1 of 10 newtons along x-axis. I want to represent this. I simply draw a line. This line is along x-axis and it has a direction, magnitude of 10 centimeters. Supposing I want to show a force of 5 newtons along x-axis. As many of you have guessed, it will be a line or a ray which is along x-axis, but the magnitude will be half of the magnitude of the earlier line, 5 centimeters. Now, if you wish to denote a vector 5 newtons at an angle of 30 degrees, we simply draw a line at an angle of 30 degrees with respect to the horizontal, and the dimension of this line, magnitude, will be 5 Newton. What if I want to represent 10 meters per second vertically upwards? I will draw a line which is perpendicular to x-axis vertically upwards and whose magnitude is going to be 10 meters per second. So I might have it as 10 centimeters or 5 centimeters, whatever be the scale that I choose. Sometimes I would have to represent vectors northeast, southwest, etc. So to represent them, we have to take the exact midway between the directions. For example, this is north and this is south. So This is north, this is east. So this would be northeast, exactly halfway between them. This is how vectors are represented. There are other ways where we use 3D geometry and matrices to represent vectors, but we'll save it for a little later. When we start working on vectors, especially in physics, we will need to resolve vectors along certain directions. So now let's understand what exactly this resolution of vector is. Let's try to understand this in a simple way. Supposing an object is being pulled in a certain direction and it moves in a certain way, meaning it will cover some distance, it will have certain acceleration, it will move with certain velocity, etc., under the influence of this force. Now, the question is it possible for the same object to be pulled from both the x-axis and the y-axis in such a way that it moves exactly as it did in case 1? So one force is being replaced by two forces, a force along x-axis and a force along y-axis. And the combined action of these two should be the case 1. All right. This blue line represents the force being applied in the x direction, and the green line represents the force being applied in the y direction. And we have achieved what happened in case 1. We are quick to realize that to make this happen, both the forces along x-axis and y-axis cannot be some random values. They need to be specific values. That means we are talking about fx and fy to be specific values. So this process of finding the values of forces along x-axis, which we're calling as fx, and along y-axis, which we're calling as fy, in order to have a combined effect as the force in our case 1, is called the resolution of force. So fx is called the horizontal component of the force, and fy is called the vertical component of this force. How do we find out fx and fy? Well, we have trigonometry to our rescue. So now we are trying to find out what resolution of a vector means. Let's try to understand this with a simple example. Let's say I'm throwing a ball with a velocity of 10 meters per second at an angle of 30 degrees with respect to the horizontal. What am I interested in? I want to find out the horizontal component of this velocity, and I want to understand how this can be done. Well, let's first have our vector. Our vector is making an angle of 30 degrees and its magnitude is 10 meters per second. So we are taking a distance, the length of the vector to be 10 meters, 10 units. Horizontal component would mean finding x. Basically, we need to find x. How do I do that? We know in trigonometry, cos 30 is the ratio which involves adjacent side, in our case x, and the known value of the velocity 10 meters per second, which is the hypotenuse. Cos 30 is equal to x by 10. So x is 10 cos 30, which is nothing but 5√3 meters per second. So we conclude by saying the horizontal component of velocity, which is nothing but v along x-axis, is v into cos theta, where theta is the angle made by the velocity with respect to x-axis. If I want to find out the vertical component of this velocity, I simply drop a perpendicular onto the y-axis. And now I'm interested in finding out this length. y. So to do this, we simply complete the rectangle and we realize that the trigonometric ratio that we now need is sine 30 because that involves the opposite side in this case y. So sine 30 is equal to y by 10 or y is equal to 5 meters per second. So we say the vertical component of the velocity Vy is V into sine theta, in this case 5 meters per second. So in this session, we have understood these things. What are vectors? How we represent vectors? And how do we resolve them along x and y directions? In the next session, we will discuss about how do we add two vectors or take the resultant of two vectors. We have a quick check assessment to conclude this session. Please solve them. The solution to that will be available as a part of our next session. We hope that you will be able to answer these questions. Happy learning. See you soon. Thank you.